In this lecture, we shall discuss rectilinear motion. It deals with the position, velocity, and acceleration of a body moving along a straight line. So, first define what is velocity. If a body is at point P at time t and reaches a neighboring point P dash at time t plus delta t, then the average velocity during the time interval delta t is delta x by delta t. So this is delta x, distance covered in time delta t. So distance covered over time taken is the average velocity in this interval. Now suppose if we take the time interval is very small, then the distance covered will be very small. So that small distance over small time and time is near zero gives the instantaneous velocity at point P, and that instantaneous velocity will be denoted by dx by dt. Next is the acceleration. So if v is velocity at point P and v plus delta v be the velocity at neighboring point P dash after time delta t, then the average acceleration is velocity in this interval over time taken is the average acceleration. But if you take this delta t tend to 0, then dv over dt is the instantaneous acceleration of the body at point P. Now some remarks. If a body intends to traverse along a straight line, then it can do so in two possible directions. Suppose a body wants to move in a straight line, then it can go either in this direction or it can go in this direction. We will represent one direction with plus sign, so here the displacement will be taken positive and the other will be negative for the displacement. So in this direction, if the body is going towards right, that is if it goes far from O, we shall take its velocity as a positive quantity, and if moves towards the point O, then we shall take its velocity as a negative quantity. Similarly, in this case, if the body is moving far from point O, its displacement will be taken as negative and its velocity will also taken as negative. And if the body moves towards the point O, the displacement is still negative because it is moving in the negative side, and velocity will then be taken as positive. So here I have summarized all these things. So if a body is moving in this direction, its displacement is positive, its velocity is positive, and the acceleration can be positive or negative depending upon whether the acceleration uh, is along the direction of velocity or whether acceleration opposes the velocity. So if the body is moving in this direction, its distance or its displacement is still positive and v is taken negative in this direction, and the acceleration is positive or negative depending upon whether acceleration is along the direction of v or it opposes v. Similarly here, the body's displacement is negative if it's going in this side, the velocity is negative, and if it goes in this side, then v will be taken as positive. So let us understand this concept of sign conventions by using an example. Let xt be a displacement function which is given in terms of time. So notice that this displacement is non-negative when time varies from 0 to 6. So when you take t equal to 0, you see displacement is 0. When you take t equal to 6, displacement is again 0. But if you take any time between 0 and 6, you will get a positive quantity answer. Suppose we take t equal to 1. So 6 minus 1, that is 5. So it's a positive quantity for t equal to 1. So similarly, for any t between 0 and 6, this thing is positive. Now see what happens to the velocity. If you take its derivative, the derivative is 12t minus 3t square. This derivative means this velocity is non-negative when t lies between 0 and 4, and after that it becomes negative. So the body travels in positive directions for 6 seconds, and out of those 6 seconds, the 4 seconds it travels with positive velocity, and remaining 2 seconds it travels with negative velocity. What it means? It means from point O to some point this, the body goes from here to here and takes 4 seconds, and the velocity is positive in this direction and displacement is positive in this direction. Since this travel only 6 seconds in positive direction, it means so from here to here it will take 2 seconds, and the velocity will be negative during these 2 seconds. So after that it keeps on moving in the negative directions after these 2 seconds. So in the negative directions, x is negative, v will be taken as negative. The acceleration is the derivative of velocity 12 minus 60. This is non-negative for t lies between 0 and 2. If t is bigger than 2, the acceleration is negative. So see what it means. Now velocity is positive for 4 seconds. So when t equal to 4 or t is up to 4, the velocity is positive. But for t 0 to 2, the acceleration is positive, and after it acceleration becomes negative. So first 2 seconds the acceleration is positive, after that the acceleration becomes negative. It means the acceleration becomes then an opposing force. It opposes the motion, and finally acceleration brings the body into rest, and then the velocity becomes negative. It takes a u-turn and starts moving in this direction. Then v is negative, f is negative, and after this point onward x is also negative. Remark: notice that the sign convention fixed earlier are not arbitrarily defined. Since the displacement xt is a function of time, so velocity is the slope of the tangent to the graph and of the displacement function xt. But slope can be either negative or positive. Consequently, velocity of the particle can be negative or positive. तो देखिए हमने पहले साइन कन्वेंशंस डिफाइन की थी कि वेलोसिटी कब पॉजिटिव लेनी है, डिस्टेंस कब पॉजिटिव लेना है, एक्सेलरेशन कब पॉजिटिव और नेगेटिव लेनी है. तो मैं ये कह रहा हूँ कि ये आर्बिट्रेरीली नहीं है. सो लेट्स अंडरस्टैंड दिस थिंग फ्रॉम the following graph. So here I have drawn a graph between time and the displacement. If the displacement is in the positive direction and displacement increases with the time. So if displacement increases with time, and the velocity vector you will see has a positive slope, so velocity is positive. So after a certain time the velocity becomes 0. The velocity vector is uh, parallel to the horizontal line, and then the slope becomes negative, so velocity becomes negative. It means the first this body goes in the positive direction and then take a u-turn and comes back, and then it starts moving in negative direction. So in negative directions, the body is going far from this O. So this displacement will be taken negative, and now see the slope of the tangent. Although the slope of this tangent is positive, but still we shall take the velocity negative because the direction of this tangent vector is in the downward direction. Had this been in this direction, we would have taken the velocity positive. But since the direction is this, so we shall take this velocity vector as negative. So it means that sign conventions which we have defined uh, do match with the this calculus thing. Now consider rectilinear motion with constant acceleration. Suppose acceleration f equal to dv by dt of a moving object is constant. On integrating both sides with respect to time, we get v equal to ft plus c. Assuming that the particle started with velocity u, that is when t equal to 0, we had v equal to u. So this I assume. So put this, when t equal to 0, v equal to u, we get c equal to u. So on substituting c equal to u, we get this formula, v equal to u plus ft. Now using chain rule, we can write this acceleration as, so f is dv by dt. This can be written as dv by dx into dx by dt. We have supposed here that v is a function of x and x is then a function of t. So we can write dv by dt as dv by dx into dx by dt. But dx by dt, so dx by dt is v. So this we have written v here. So dv by dx as it is. So now integrate this equation. So first cross multiplying f dx is equal to v dv. Now after integrating, we get fx plus c equal to v square by 2. Integral of v dv is v square by 2. Assuming that the particle started with velocity u when x equal to 0, we had v equal to u. So we suppose when x is 0, that is the starting point, when x equal to 0, initial velocity is u. So when x equal to 0, v equal to u. Substituting these values in this equation, we get, substituting these values in this equation, we get v square minus u square equal to 2fx. The last equation can be written as v minus u into v plus u equal to 2fx. Our last equation was v square minus u square equal to 2fx. So we have factorized last equation as v minus u and v plus u. And we had one, this equation v is equal to u plus ft. From here v minus u is equal to ft. Substitute v minus u equal to ft in this equation. After substituting for v minus u equal to ft and cancelling f from both sides and then cross multiplying, bring t down here and 2 down here, we get v plus u over 2 equal to x over t. That is arithmetic mean of initial and final velocities is equal to the average velocity. So again put v equal to u plus ft in the last equation. If we put v equal to u plus ft here, we get u plus ft plus u by 2 equal to x by t. And this is 2u and this 2 cancels, u plus ft by 2 cross multiplying by t, we get x is equal to ut plus half ft square. So we have got three formulas for studying rectilinear motion of a body. In case acceleration is the opposing motion, that is if it is a retardation, then we shall replace f by minus f in each of the above formula. So we shall get three more formulas. So this was all about the governing equations of a rectilinear motion. So in the next lecture, we shall do some questions. Thank you very much.